Concept 2, finding the nth term of an arithmetic sequence. So if I am looking at my arithmetic sequence here, my first job is to find my common difference. So 6 to 10, that's going to be 4. 10 to 14, another 4. And 14 to 18 is another 4. So it looks like this is an arithmetic sequence, and 4 is my common difference. My first term is going to be 6. That's easy, right? I've got it right there. And we're going to represent that as a sub 1, right? Or the first term, okay? My second term is going to be my first term plus the difference, right? So my first term plus this is going to equal 10, okay? First term plus the difference equals 10. My third term is going to be my first term again plus 2 times the difference, okay? Because I'm going over once, over twice. So I can just multiply this by 2. I don't even have to worry about this 10 because I know I can skip straight to 14 if I add 2 differences, right? So 6 plus 2 times my difference, or my first term plus my difference times 2 equals my third term, okay? Fourth term looks to be the same thing. It's my first term plus 3 times the difference. Okay, I'm going over 3. So 6 plus 3 times 4. Or my first term plus my difference times 3 equals my fourth term. Okay, and that's good for the first 4 terms. But when we're trying to find some other term, okay, and it could be the 5th term or it could be the 20th term, it's going to be a lot harder to go through and count all of these or be able to go on from a number we've already got. Okay, so we need to come up with a formula. And it looks like we've got a pretty good start. We've got a pattern we can see showing up. Okay, so I'm going to have this be my first term, okay, plus, oops, formatting, plus, well, now this becomes a problem because I don't know what term it is. And right now I've got a number in there. But what I can see is that this 2 times the difference is 1 less than that term. This 3 times the difference is 1 less than that term. So I could actually write this as the n minus 1 times the difference, right? And that should get me to be the same pattern as these ones, all right? So that, for my numbers, is going to be 6 plus my, well, I don't know what n is going to be, but I can just choose one. Let's say it's 20. 20 minus 1 times my difference of 4. 20 minus 1 is going to be 19. 19 times 4 should be 76. 76 plus 6 would mean that this should be 82. So my 20th, or my 20th term should be 82. All right, and we can check that out later. And then the last part, and this is really where my formula comes in, is to set it up algebraically. Okay, and I'm going to actually make a copy of this because that'll be easier instead of changing around all my formatting. Okay, so I am going to have my first term that stays the same, and I'm going to add that to my difference, but what I've got here and what I've got here tells me that this should be an n minus 1, where this n and this n are the same. So whatever term I'm looking for, I'm going to do the first term plus the difference times that term minus 1, and that'll get me the value. Okay? And that's my formula. And here it is right here, written out just slightly differently. Okay? So now let's do it. Okay? So for this arithmetic sequence, we'll start off, we've first got to find the common difference. Even though these are negative, between these two terms, I'm increasing by 3, increasing by 3, increasing by 3. Finish that 3 there. Okay, so my common difference is 3. And then I'm going to use my formula to find the nth term. So I'm just going to plug it in. So right here, my first term is negative 8. And then my common difference is 3, positive 3. And then my nth term, again, we can choose whatever. We could say, we'll just go with 12. Okay, 12 is my common difference. Or, sorry, 12 is my nth term. That's what I'm looking for. I'm looking for a to the 12. Okay, so this will be 11 times 3, or 33, plus negative 8. And that looks to me like that would be 25. A 12 equals 25.